Hello my dear students, this is P. Venkateshwarlu, PGT Physics. In previous video, we have to discuss about applications of Bernoulli's theorem. In this video, so we have to discuss about viscosity. What, my children? Viscosity. Viscosity. So viscosity is the properties of fluid. It is the properties of fluid. Means viscosity, it is the properties of fluid. So it is the one type of friction between the layers of fluid. Okay, see here. See, we can consider friction. Friction means what? When one body moves on another body. Okay, so if force is applied on the body, here between the two bodies, friction force comes into play. Understand? So when solid body moves on another surface, here what happened? My dear children? See here, when body moves on another surface, between the two surfaces, a force comes into play. That force is called friction here. Here is friction. And coming to fluids. So when a layer of the fluid is flows on another layer. Okay. So liquid flow means it is laminar flow. Okay. What happened? Liquid is there. So in liquid, layers are formed. So one layer moves with one and another layer of the liquid or fluid moves with different velocity. Okay, in this case what happened? Okay, suppose it is a pipe. Okay, it is a pipe. So in which fluid can flow? In this case what happened? On the axis of pipe, we can get maximum velocity, and continuously at the end, and both ends of the surface, the velocity becomes 0. Okay, so consider a pipe in which middle of the line gets maximum velocity, and above and below along the surfaces of the pipe, velocity becomes minimum. See, in this case, between one to another layer, some friction is there. That friction is called viscosity. What, my children? That friction is called viscosity. In this case, what happens? Here, consider the fluid layers. If one layer moves forward means, okay, because that is pulling back lower the layer. Okay, so if one layer moves forward means that pulls back into lower of the fluid layer. Okay, understand? One moves forward means another pull backward. Okay, in this way, the force of friction comes into play between the layers of fluid. That friction is called viscosity. What, my children? What is viscosity? Viscosity is a type of friction between the layers of fluid. Okay, so in which is opposed relative motion between the layers of fluid, which is always opposed the relative velocity of the fluid layers. Coming to causes of laminar flow. What are the causes? Yes, laminar flow. Okay, so before now I am explaining laminar flow. Laminar flow means fluid can flow with the layers. Okay, already I said now Okay, so layer by layer liquid can flow. So in which if one layer moves forward means lower the layer full backward. Okay, so in this way the fluid can flow. Okay, understand my children? Next what my children? Coefficient of viscosity. Coefficient of viscosity. Coefficient of viscosity. Coefficient of viscosity. It is denoted eta. It is denoted eta, my children. Eta. So coefficient of viscosity, which is defined as force per unit area. Force per unit area to the velocity gradient. Velocity gradient, my children. Okay, or velocity gradient we can say strain rate, or this velocity gradient we can say strain rate. Understand? See, force per unit area we know that force per unit area. So then velocity gradient it is denoted dV by dx. Okay, so velocity per unit length. What means that velocity per unit length is called velocity gradient. Or otherwise you have to take strain rate. Strain rate means what means that change in length by original length into time. Okay, understand my children? Strain rate means dl by l into 1 by t. 1 by t we can say strain rate. So in both we have to take any one. So what, my children? Coefficient of viscosity, which is defined as the ratio of force per unit area to the strain rate, strain per unit time, or otherwise you have to take velocity gradient. What, my children? Velocity gradient, velocity per unit length is called coefficient of viscosity, dV by dx. So what, my children? Then finally coefficient of viscosity, it is denoted eta. Eta is equal to force per unit area to the velocity gradient. Understand, my children? Velocity gradient. So by rearranging this we can get different formula. Okay, so means what, my children? Then eta is equal to f by a dx by dv. Okay, understand, my children? So coefficient of viscosity, which is defined as force per unit area to the velocity gradient. Units and dimension formula. For coefficient of viscosity. So what is coefficient of viscosity? It is denoted eta, force per unit area to the velocity gradient. Okay, unit. What is the unit? Newton meter square into meter per second. Understand? Rearrange this Newton per meter square second. Understand? So Newton per second per meter square is the coefficient of viscosity SI unit. Its SI unit is what, my children? Based on the formula force Newton, area meter square. This one becomes reverse. Meter per second. Meter per second, my children. Okay, by rearranging this Newton second per meter square, it is the SI unit. And CGS unit, my children. Dyne per second per centimeter square. Understand my children? Dyne per centimeter, dyne per second per centimeter square. Understand? So we can say it's easy as pies. Okay, so this we can say pies. Okay, so in SI unit pies only. Pies only. Okay, understand my children? Pies only. Okay, my children. So Newton second per meter square is called pies only. And CGS dyne second per centimeter square. Dyne second per centimeter square. Okay, so we can say 1 pies only. 1 pies only is equal to 1 pies only is equal to 10 pies. 10 pies. So this is the relation between SI system and CGS system. Okay, understand my children? So this is the SI unit of coefficient of viscosity. So that SI unit is what? Newton second per meter square. So this we can say pies only. Coming to CGS system, dyne second per centimeter square. Okay, we can say pies. 1 pies only is equal to 10 pies. Okay, so 1 pies only is equal to 10 pies. So this is the conversion. So from CGS to SI, it is a scalar quantity. It is scalar quantity. And its dimension formula what, my children? Dimension formula. So dimension formula what, my children? Newton means m power 1, L power 1, T power minus 2 per meter square. Meter square means L power 2 into second T power 1. T power 1. So by cancelling what we can get? M power 1, M power 1, L power 1, L power 1 gets cancelled. L power minus 1, T power minus 2, T power plus 1, T power minus 1. Understand my children? So this is the dimension formula. This is the dimension formula for coefficient of viscosity. Coefficient of viscosity. Understand my children? Yes, we know that coefficient of viscosity, which is defined as the ratio of force per unit area to the velocity gradient. Its SI unit is Newton second per meter square. Its CGS unit is called dyne second per centimeter square. So we know that in CGS system we can say pies. In SI system we can say pies only. 1 pies only is equal to 10 pies. Okay, it is a scalar quantity. Its dimension formula m power 1, L power minus 1, T power minus 1. So coming to relative viscosity. Relative viscosity. Relative viscosity. Okay, so relative viscosity, which is defined as it is the ratio of viscosity of the liquid to the viscosity of water. Okay, so relative velocity, it is denoted n relative, so which is equal to coefficient of liquid to the coefficient of viscosity of water. Understand me, children? Okay, so this you have to written eta is equal to eta liquid, eta water. Comparison of coefficient of viscosity with liquid and with water, we can say coefficient of relative velocity or relative viscosity. Relative viscosity, which is defined as the ratio of viscosity of liquid to the viscosity of water. Okay, so we know that blood the viscosity of blood 0 to 37 degrees is constant. Okay, So understand 0 to 37 degrees constant. Okay, relative what matters? Relative viscosity. Relative viscosity matters. Understand this viscosity, cause of viscosity, coefficient of viscosity, and it is coefficient of viscosity units, it's SI units, and relative viscosity matters. Fluid friction force. Coming to fluid friction force. Fluid friction force matters. Okay, see here how we can get the fluid friction. We know that. So we know that when solid moves on another solid, friction force comes into play. So when fluid flows one layer to another layer, we can get the fluid friction. So how we can determine? Okay, so consider two layers. This is one layer and this is one layer. Okay, understand here the lower level having velocity v. Okay, see here what happened when upper layer moves forward means, okay, so the velocity increases dv by pulling back of lower layers. Okay, so this is the way we can get the fluid friction. Okay, so from the coefficient of viscosity what? Force per unit area and velocity gradient. Okay, the ratio of force acting per unit area. Okay, so then dv by dx. Okay, we can say shear strain. So liquid, these fluids are exert shear stress. Okay, understand? So the fluid flow like this. Understand? So from this we can get fluid friction force. So by rearranging this we can get. Okay, understand my children? Okay, n into dv by dx is equal to force per unit area. Understand? Then after F is equal to n eta into a into dv by dx. Rearrange this, F is equal to eta a dv by dx. Understand? So this formula will use the force of what we can say medicine. Okay, so force of friction of the liquid flow, fluid friction force. We can say medicine fluid friction flow. F is equal to eta a dv by dx. Eta into a into dv by dx medicine. Understand medicine? Fluid friction force. Fluid friction force is a type of force. Okay, when it is developed means when the layer of the fluid moves on the another layer of the fluid, means same fluid but it flow is like a layer by layer flow. Okay, understand my children? Coming to their difference between fluid friction and solid friction. Okay, understand my children? Differences: solid friction, fluid friction and solid friction. Okay, understand my children? Here coming to this viscous force or fluid friction depends upon area. Okay, it depends upon area. Okay, understand? So this fluid friction depends upon area, but solid friction is independent mindset. Understand? So fluid friction which is depending upon the area of the fluid layer. If area of the fluid layer increases means their friction also increases. In the case of solid friction, this solid friction will not depends upon area. Understand, my children? So it is directly proportional to relative velocity. Means relative velocity increases. Relative velocity means what? The relative velocity of the one layer to another layer. The difference of speeds of the layer, we can say relative velocity. So this fluid friction is depends upon the relative velocity. If relative velocity increases, then friction also increases. Understand here, independent of this relative velocity. So coming to next point, okay, independent of normal force. Understand? So here fluid friction is independent of normal force. Here solid friction is depends upon normal force. Normal force, it is denoted as. Okay, how you can say normal force means when body is placed on the another body, here normal reaction or normal force is acting. If force is acting perpendicular to the surface is called normal force. Understand? So this is about the differences of solid friction and liquid friction. Depends. Solid friction is independent of area, but liquid friction is depends upon area. And so solid friction is independent of relative velocity. Here liquid friction is depends upon relative velocity. And solid friction is depends upon what mentioned like what? Yes, normal force. But normal force, which is here fluid friction is independent of normal and depends upon solid friction. Okay, my children.